Hello, so in today's video, we're going to look at proving that a rational number plus an irrational number is an irrational number. So this is going to be another proof by contradiction proof. So this is another proof by contradiction. So we're going to assume that our conclusion is actually incorrect. We're going to actually assume that our conclusion is that a rational number plus an irrational number gives you a rational number. So we're going to assume to the contrary. So assume to the contrary that a rational plus an irrational actually gives you a rational. Now, obviously, again, this is not true, but this is a proof by contradiction. We're going to assume that the opposite conclusion is true. And then from that, we're going to derive that actually our initial assumption here cannot be true. So what I'm going to do is I'm going to let A be the rational number. So I'm going to call A the rational number. So let A be rational. So again, this Q notation is the set of rational numbers. And I'm going to let B, so the letter B, be irrational. So if A is a rational number, then that means we can write or express A as a fraction of an integer over an integer. So therefore, A is equal to, I'll call it N over M. So N over M, where N and M are integers. So again, rational numbers are numbers that we can express as a fraction of an integer over an integer. So two integers, M and M. M will not be equal to 0. Obviously, you can't divide by 0 in math. So I'm just going to make clear that M is not equal to 0. Okay, so what we're going to do is we're going to add the two numbers together and see what we get. So therefore, A plus B is going to be equal to N over M plus B. So N over M plus B, because again, A we're going to call N over M. And if we just simplify if we just combine a common denominator, so really this is N over M plus BM over M, which is the same as N plus BM over M, because now we've got a common denominator of M. So N plus BM over M is our result there. So we're going to assume that this is a rational number. That's what we want to assume in this proof. We're going to assume that this is rational. So therefore, this is a rational number by our assumption. So therefore, this means that this fraction N plus BM divided by M is equal to another fraction. Let's just call it, I don't know, let's just call it J over K. So J over K, where J and K, so J and K, again, are just some random integers. But of course, K is not equal to 0, because again, we can't divide by 0. So we've got this rational number, and we're just going to express it as J over K, where J and K are integers. So the key thing is that N and M are integers, and J and K are integers. So what I'm going to do now is I'm going to try and rearrange this formula, this equation, and I'm going to make B the subject to the formula, because B is the irrational number. So we're going to see what we get when we do that. So when we do that, times both sides by M, we will get N plus BM is equal to J over K. Well, JM over K. I'll write it like this instead. So J M over K. I'm then going to take away N from both sides. So I get BM is equal to JM over K, subtract N. I'm just going to actually get a common denominator again, a common denominator of K. So JM over K, take away NK over K. And then this is going to be the same as, again, if I just keep the writing all on the same page. This is now going to be exactly the same as, so BM is equal to JM, take away NK divided by K. I'm now going to divide both sides by M. And if I do that, I get B equals JM minus NK over K times M. Now, okay, so we've got JM on the top, J times M, take away N times K. Now J, M, N, K, these are all integers. So this is a whole number, take away a whole number. So again, that's going to be another whole number. So you've got an integer on the top, and then K times N, again, K is an integer, m is an integer. Integer times an integer, whole number times whole number, that must be a whole number. So you've got another integer on the bottom. So that means that this fraction here is going to be a rational number. So this must be a rational number. But this is a contradiction. This is a contradiction. And why is that a contradiction? Why does that contradict what we assumed? Well, we assumed that B was irrational. So we assumed at the start that B was irrational. We called B our irrational number, and yet we just concluded that B is rational. So let's just write this here clearly. So this is because we assumed that B is not rational. So B is not in the rational number. So B is irrational. So therefore, we've proved that a rational number plus an irrational number, so therefore a rational plus an irrational cannot possibly be rational, so it must be irrational. So it's going to be an irrational number. So that's how you prove this proof. So again, it's another proof by contradiction example. So you want to assume that actually a rational number plus an irrational number is a rational number. And then you can do the maths. You can use the definition of a rational number, do the maths, and then you can get this conclusion, this contradictory conclusion that B is rational when actually we assume B at the start to be irrational. So that's how you prove that, yeah, a rational number plus an irrational number is irrational.